We visited calculus earlier. Let's just recap this thing called the first derivative. Different notations that we can see. Y dash, sometimes called Y prime. You might hear people use that terminology. F dash x, so the function but with the dash or the prime. Sometimes we just say d dx of whatever the function is that we're differentiating. We say, hey, this function we're differentiating with respect to x, and quite possibly the most common of them all is dy dx, or whatever the pronumerals are we're using. The d, I guess, comes from the Greek letter delta, which we often use to represent change in maths and science for that matter. What does it measure? Well, if we're talking about a curve, it basically measures the slope of the tangent at that particular point. Now, we usually just say it's the slope of the curve. We don't say it's the slope of the tangent to the curve. It's just understood that that's what we mean when we say slope of the curve. We're actually talking about the tangent to the curve at that point. What can we tell? Well, if that tangent has a positive slope, then the curve must be going up. So we say it's increasing in value. And the flip side of that, if it's a negative number, then the tangent has a negative slope, the curve must be going down. And of course, in between positive and negative, we get 0. That's when it's not going up, it's not going down. So we say it's stationary, it's not moving at all. I'm going to just draw a really rough sketch with only using the first derivative to get a picture. So we've got this curve, it's a cubic, 3x squared minus x cubed. Now, of course, we've got lots of other ways we could do it. This is just another tool that we've got at our disposal. We're going to find those stationary points and determine their nature. So what sort of stationary point are they? And what I mean by that is, well, is it a maximum? Is it going up, stopping and then coming back down? Or is it a minimum? Is it going down, stopping and then coming back up? And then a rough sketch, and it is going to be a really rough sketch. We need to find the tool that allows us to find the slope of the curve, that being the derivative. That's the first thing I do. Dy dx is 6x minus 3x squared. When you are setting out your solutions, remember, it is a solution for someone else. It's not for you. They want to be able to read your solution, understand what you're doing. So you write these things down. Don't just go, oh, derivative equals 0. Because the person reading your solution is going, well, why are you making it equal to 0? What's so important about that? Explain to them. It's like your reasoning. This is why I'm doing this. Stationary points occur when the derivative equals 0. I know that. You see, in this question, we're trying to find the stationary points. So I've written that down. Well, hang on, I know this fact. That means 6x minus 3x squared must equal 0, which I can solve, and I come up with these two possibilities for stationary points. X equals 0, x equals 2. They, of course, are just the x values. We can substitute back into the function, work out the y values. But it did say determine their nature. We will learn other ways of doing it, but at this stage, all I'm using is the first derivative. So I draw myself up a little tiny table of values. 0, 0 is the point I'm investigating. I'm interested in when x equals 0. But remember, I want to work out, is it going up, stopping, coming back down, or is it going the other way around? So I have a look either side of the point. That's why I put 0 in the middle here, and what I'm saying is, at that point, I know it's stationary. So its value is 0. I've just drawn a horizontal tangent. I've got a horizontal tangent at that point. I need to pick a point on the left-hand side, which we often call the negative side, and I need to pick a point on the right-hand side. Now you can pick any number you like. The only proviso is you don't go past another possibility for a stationary point, and you don't go past any discontinuities in the domain if it has any. Now this one doesn't have any, we're talking about a polynomial. But when I go to the right hand side, I can't go past x equals 2, because that's another possibility. I'm going to pick negative 1 on the left hand side. I can go as far as I want on the left, because there's not another stationary point, there's not a discontinuity, I can go as far as I want. I just picked an easy number to substitute in, negative 1. Write down the number you're substituting in. Let them know, this is the one I'm testing. And its answer, it's negative 9. Alright, it's negative, so I know my tangent is going down like that. Pick one on the right hand side, not a lot to choose from, because if I'm smart, I'm going to use a whole number, a lot easier to substitute in. So I'll pick the number 1, and that one turns out to be positive 3. And I look at those tangents, and I've got a nice little picture there. Oh, I can see what it's doing. So this would be a minimum one. It's coming down to some minimum, going back up. Let's test the other one. 2, 4, same deal. 2 goes in the middle. I know that's got a horizontal tangent there. I need to pick a point on the left-hand side, or the negative side of 2, and one on the right-hand side. Let's not waste time. I've already tested 1, so I may as well use that again for this one. So 1, there it is, going up. Right hand side, again, I can pick any number I like. What did I go for? Yeah, I just went for the next integer, 3. Substitute in, -9. Okay, there's my little picture. I can see what it's doing. 2, 4. It's a maximum. Draw a rough sketch. As I say, it is going to be a really rough sketch. Let's plot in these points, 0, 0, and there's 2, 4 up there. I know, look, the picture itself should tell me that that's going to be a minimum, that's going to be a maximum, but we found that information out. And there's a very, very rough sketch. I have not bothered to find the x-intercept, although I suppose it's not that hard for this one, but it's just a sketch. It's not an accurate graph, it's just a sketch. Okay, so 4a and 4b is just using this idea of the first derivative to sketch graphs, things like that.